So today I'm trying this hard problem, max.product of two subsequences. So we are given two arrays, we want max.product of non-empty subsequences, okay, whatever. 2 minus 2, 3, 6, that's 18. What if you take 2 and 5? Yeah, you need negatives from. Well, this clearly wants to be cubed time complexity, so you just have to figure out what it is. I would do this in Python. I mean, the initial guess is to have 3 dimensions. Well, let's say I have like dp ijk. I mean, does it really have to be ijk? What if it's just ij? And now it's max of dpi minus 1j minus 1 plus nums I1 nums 1i times nums 2j, or we can do this should work, I guess. So let's call and let's call dp with, I don't know, let's return this. Is under 0, we want to return to maximize it, so let's return. We can have what, 1 million, so 500 million, so we want like 10 to 9. Let's do this. Great. Nums 1i times nums 2j plus dp j minus 1 dp I guess. Yeah, that's the problem with negative ones. So I can like k 0 if k, let's call it flag. True, and here we pass f, and here we pass f, and here we pass f. This should work. Okay, it didn't work. That's a little weird. Res print oh, because we should return minus infinity. I mean, this could pass. Okay. That was extremely easy. What the hell? What? Let's do it quickly in C++. Okay. Now what's the base case? Let's fit this with I'm not sure actually if it won't overflow, but okay. So we got that, and then let's see. Well, we know that dpij is max of but problem is that some of those can be fine. So let's say I took one here I can take max of right. From here I can only take the one that already had it set. From here I can only take the one that had already set. And this one can already be set, and one is here, and then dp 0, 0, 0 is 0. I'm missing this, but okay. Okay, and then finally return dp nm1 or something like that. I don't know, 18, 21. Why 18? All 3 and 7. Interesting. Yeah, that's fair. That is weird, bro. How is that possible? I mean, you probably want to pair this with this and then 9 with 5. But then 3 with 1, and then you can do 3 with 9. That's 27 plus 90 is 117. Maybe like that. Okay, that worked. So how about we initialize it like this? I already found it out. This is 0 and this is negative infinity. Okay. Great. I am extremely slow and I'm not sure why. Maybe because I don't need to allocate this entire thing. But I really don't want to do DP swapping, so whatever. Let's check editorial top down DP. Okay. It's n times m bottom up, space optimized. Okay, nothing interesting. Let's write a solution. Let's solve the subproblem for problem for each nums 1 0 I and nums 0 j. The answer for them is can either pair their last elements or not pair them. If we do not pair them, we try all combinations of skipping some numbers, e.g. compute the answer for j minus 1. You can notice we will solve some subproblems many times, so we use memoization and boom, we have a dynamic programming solution approach. We have to take at least one pair of numbers, so we have a third dimension in the DP table, which denotes if we have already taken some pair or not. Then when calculating dpi, then dpij0 is 0 for all ij, and dpij1 when computing, we can either take the pair nums1i, nums2j, and and add it to the maximum of dpij0, dpij1, or we take maximum the three other options. We also consider the three options already mentioned of an m, where n is the size of nums1 are the sizes of nums1 and nums2. Each of NM's cells of the BP table, we do O1 of work, O of M, if we notice that we do not need the entire table, just the last two rows. Note that I did not implement the space optimization in this code. Post. Good night.